All right, so let's take a look at some more practice problems using expressing the numbers in powers of 10, but this time we're going to be expressing them using engineering notation. Unlike before, I was asking for you to express the numbers in scientific notation. This time we're going to be using engineering notation. So the difference between engineering and scientific notation is just the range. So scientific notation was greater than or equal to 1, and the number had to be less than 1. But engineer notation is the number has to be greater than or equal to 1 and less than 1,000. So you can go all the way up to 999.99999. As long as it's less than 1,000, that number is considered to be an engineer notation. And the other thing is that the exponent you move has to be a multiple of 3. So for this first example, 87,000. So of course this number is greater than 1,000. So we want to make it smaller. So to put it in engineer notation, we start moving in multiples of 3. So 1, 2, 3, and then we evaluate. Okay, so if we make this number move this decimal 3 places to the left, makes this number smaller, so it'd be 87. 87 meets this criteria, so therefore this number will be in engineer notation, and it will be written like this: 87 times 10 to the what? Just like before, right? We have some rules over here whenever we're moving the decimal. So we're making this number smaller, so we need to make the exponent bigger. So we move it three places to the left, so this would be 87 times 10 to the third. All right, so the next one, 957 million. Of course, this number is way too big, so we start moving our decimal to make it smaller. 1, 2, 3. And keep in mind, we're in engineering notation, so we want to move in multiples of 3. Multiples of 3. So it's 1, 2, 3, 4, 5, 6. So we can stop right here. So, but if you find yourself going too far, let's say that you went like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. That number will be 0.957. So this doesn't meet this criteria. So this is less than 1. So we know we went too far. But just to do it over, 1, 2, 3, 4, 5, 6. So this number would be in engineering notation written like this: 957 times 10 to the 6. All right, so let's look at some smaller numbers. So we just do the same thing, but this time we're trying to make the number larger. So therefore, the exponent is going to be smaller, and we're going to be moving in multiples of 3. So 1, 2, 3. This is 0.25. That's still too small. Let's move it 3 more times. 4, 5, 6. Now, what we're going to do right here, we're just going to add a 0 to this one right here. So this number in engineering notation will be written like this: 250 times 10 to the minus 6. All right, so let's take a look at the last example. So we're moving in multiples of 3. 1, 2, 3, 4, 5, 6. Still too small. 7, 8, 9. And we just add ourselves a 0. And so this number will be 442. Oh, excuse me. This number will be 420 times 10 to the minus 9. So pretty straightforward. Just remember that this criteria for engineer notation, the number has to be greater than equal to 1 and less than 1,000, and you want to move in multiples of 3. So these exponents of the power of 10 need to be a multiple of 3. So like for example, if you came down here, made a mistake and said it was 25 times 10 to the minus 5. Well, of course, this 25 meets the engineer notation criteria, but the exponent is not a multiple of 3. So hopefully these few examples helped your understanding of expressing numbers in engineering notation. If you are still having issues or questions about it, feel free to reach out to me. Thank you.